Welcome. Each month I like to put out a video describing what happened over the last month on the Sun. This video covers the time of March 2020. I hope you will enjoy. I like to start these videos out by showing a movie of the Sun in various wavelengths. And the first one, as usual, is going to be from the Solar Dynamics Observatory HMI instrument. And this is going to be a magnetogram movie. So this is a movie of the magnetic features on the Sun. And the thing you need to know is that light colored features here are positive magnetic fields. That's magnetic fields coming towards you. Dark colored features are negative magnetic fields, and that's magnetic fields moving away from you. Now we are in the transition between solar cycle 24 and solar cycle 25. So some of the regions you're going to see are old cycle regions, and some of them are going to be new cycle regions. And how can you differentiate? Well, the easiest thing, and I'll have more on this later, but the easiest thing at the moment is if the region is somewhere near the equator, then it's probably an old cycle region. And if it's at high latitudes, then it's likely a new cycle region, a solar cycle 25 region. So enjoy. Now the movie I just showed you was from the surface of the Sun, the visible surface of the Sun that you would see if you looked up at the Sun today. But as you go higher in the atmosphere, the Sun gets a lot hotter. So the next line we're going to look at is from the Solar Dynamics Observatory AIA instrument, and we're going to look at helium-304. The temperature of that line is about 50,000 degrees Kelvin. So this is much hotter than the surface, which is about 5,700 degrees Kelvin. But it's not as yet as high a temperature as you see in the corona. That will come next. Now what can you see in this movie that you couldn't see in the other one? Here you see prominences and filaments on the Sun. Filaments are the dark features across the surface of the Sun, and prominences are those bright clouds above the limb of the Sun. They are in fact actually exactly the same thing, but they were just observed differently originally, so they've been called something different just by tradition. So let's enjoy 1 month's worth of helium-304 movie of the Sun in March of 2020. Next we'll stay with the AIA instrument, but we're going to look at a much warmer line. This is an iron line at 193 angstroms, and its characteristic temperature is about 1,000,000 degrees. Oddly, this is called the low temperature corona. The temperature of the corona can be as high as 3 or 4 million degrees, say around active regions and sunspots, and if there's a flare it can go up to 20 million degrees. That's why we call this the low temperature corona. But you get to see the hotter outer layer, or at least the beginnings of the hotter outer layer of the Sun in this particular line. Last, but by no means least, we go to a different spacecraft, the SOHO spacecraft, and look at the data from the LASCO instrument. This is a coronagraph, so we're looking at a coronagraph movie, and that shows us the vast outer layers of the Sun. And what we're looking for here are eruptions away from the Sun. You'll see them happening off the east and the west limb, that's to the left and to the right respectively. And if those things should hit the Earth, then we could get a geomagnetic storms and all the disruptions associated with one of those, including to our power grids. So here is the LASCO movie for March of 2020. As you no doubt noticed in the videos I just showed you, the Sun has been relatively quiet for the last few weeks. That is because we're in the doldrums between two cycles. Solar cycle 24, shown here in red, was a fairly anemic cycle to start with. And so now we're waiting for the onset of solar cycle 25. Now, there are two models here that show what the possible onset should look like. There's a dashed curve, which has a fairly steep rise, and a dotted curve that is much slower, much more akin to what happened last time around. Now, if the solar activity seems to follow the dotted curve, which at the moment it seems to be doing, we will probably end up with a cycle very similar to solar cycle 24. However, if solar cycle 25 starts to rise suddenly, as shown by the dash curve, then we could end up with a much larger solar cycle than last time around. So only time will tell. Some people believe that these very low solar conditions that we're suffering from at the moment will go on for several decades, and we will get into a grand solar minimum. However, there's absolutely no scientific evidence that that is going to happen, and so we'll have to wait and see, but I think they're wrong. So what we're looking for here at this time is the handover from one cycle to another, a decrease in the number and strength of the regions that we see associated with solar cycle 24, and an increase in the number and strength of cycle 25 regions as they appear. How can we tell the difference? Well, let's take a look. As I mentioned, there is one way of telling whether the sunspot region you're observing is an old cycle or new cycle, and that's by looking at the latitude of the region. So we're going to try to determine whether that region in the top left hand corner of the sun, that's the northeast corner of the sun, is from cycle 24 or from cycle 25. So the first thing we need to do is to put a latitude grid on the sun. There it is. And let's mark the equator on that, which is that red line there. Now you'll notice that the red line is slightly north of the center of the sun. That's because the poles of the sun tilt towards and away from the earth at different times of year. That's called the B angle, and you have to allow for that when you're looking at these regions. But clearly this region is well north of the equator. It's at 30 degrees north. So this implies that it's a new cycle, a solar cycle 25 region. Another way of doing this is to look at the polarity of the magnetic field. If the polarity of the leading spots in this group are negative, i.e. it's a dark magnetic field going away from you, then that is a solar cycle 24 region. And if it's a positive magnetic field, then it's a solar cycle 25 region. And so this region here is obviously got a light color leading, so that is positive magnetic field, so it's likely to be solar cycle 25. And it's also at high latitude, so it's very likely to be a solar cycle 25 region. In the other hemisphere, that's reversed. If you have positive leading and it's close to the equator, then it's likely to be solar cycle 24. And if it's negative leading and at high latitude, then it's likely to be solar cycle 25. Now these polarities reverse during the solar cycle. That's why we can tell the difference between them. So this region that we're looking at is definitely solar cycle 25. And you can do that for all of the regions that come on the sun. We've had a grand total of 3 sunspot regions appear in March. All of them relatively modest. The first one appeared in the southeast quadrant of the sun on March 7th. You can see it ringed here in the left-hand picture. It was just a tiny pore. The second region appeared on March 18th. It didn't last very long either. But it was in the northeast quadrant of the sun. And just a few days ago we had another much stronger region appear near the northeast limb, and that region is still with us today. All 3 of these regions were at high latitudes. All 3 of them were reverse polarity from the solar cycle 24 regions, so all 3 of these are solar cycle 25 regions. We had no solar cycle 24 regions appear during March. In fact, it's been 2 months since we've had one of those. So this seems to imply that we are in the handover stage from solar cycle 24 to solar cycle 25. And so I'm expecting to see more and more solar cycle 25 regions that will last longer and be bigger and stronger, and fewer solar cycle 24 regions which will be weaker and last less long. So let's take a look at the trend in solar cycle 24 versus solar cycle 25 regions over the last year or so. In the early part of 2019, there were quite a few old cycle regions, and some of them were quite long-lived. Towards the middle to the end of that last year, the numbers seem to have declined a little bit, and in the last few months, they've declined quite sharply. So we have overall a downward trend in the number of old cycle regions. Now let's take a look at the trend for solar cycle 25. Here I've marked them in red. In the beginning part of 2019, there were relatively few solar cycle 25 regions. In the middle part of the year, the numbers started to increase a little bit, but in the last few months it's increased quite significantly. So we have the opposite trend in solar cycle 25. So it looks as though we're well underway into the upswing of solar cycle 25. In fact, we may well be past solar minimum, which might be as recently as the middle to late part of last year. As some of you have no doubt realized, dealing with the statistics of sunspot groups is fairly dicey at this time of the cycle because there's so few of them. You're dealing with the statistics of small numbers, so it's hard to draw concrete conclusions. But there's another way of doing this. You can look at another feature on the Sun called bipoles. These are like tiny active regions that just haven't quite made it to produce sunspots. I've shown one here with a blue arrow on the right, and if you look at that picture you can find there's dozens more. Now if you go through the magnetograms each day and choose the number of bipoles that have one polarity or the other polarity in each hemisphere, you can divide them into new and old cycle bipoles. And this is what I've done here. If you go back to January of 2019, the number of new cycle bipoles was less than 40%. But recently that number has jumped to over 50%. And now the uncertainty on these points is about 5%, and that's shown by the double arrow in the top right hand corner. So you can see that this change is indeed significant, and we've transitioned from largely old cycle bipoles to a majority of new cycle bipoles, and that's true actually of both hemispheres. Both hemispheres are now above 50%, the south being slightly ahead of the north, but both now are above 50%. So it does look as though we are changing from solar cycle 24 to solar cycle 25, even on the small scale magnetic fields. So what can we conclude from all of this? At the moment we have a mixture of new and old cycle regions. This is typical of solar minimum, the transition between one solar cycle and another. The number and longevity of old cycle regions is decreasing, while the number and longevity of new cycle regions is increasing. The southern hemisphere is leading the northern hemisphere slightly, but not necessarily will be that way for the rest of the time. If you enjoyed this presentation, please subscribe and you'll get notifications that there'll be other presentations on their way of a similar nature. If you know of somebody that might benefit from looking at this, please pass on the link to them. That'd be much appreciated. So until next time, goodbye.